What's up, YouTube? The other day I went to Goodwill store and I found this Monster Power HTS 1000 MKII surge protector. I bought it for $1, so that was a pretty good deal. Uh, I really like this unit. I like the look of it. It looks well built. It's pretty heavy, about 4 pounds, and made mostly of aluminum with the ends made of plastic. Uh, anyway, when I got home, I plugged it in. I noticed that it made a buzzing sound or a faint humming sound. I can hear it, but the camera probably can't record it. So today I'm gonna try to open it up, see what's causing the buzzing, and fix it. And if I can't fix it, so what? I only paid $1 for it. Uh, Stay tuned. So before I open it up, I went to YouTube and see if anybody else had the same problem. And it looks like it's a pretty common problem that people have with these units. That over time, as they age, uh, they just start making that buzzing sound. And if I look in the back, there's a date code. It's upside down, but it's manufactured in 2006 September. So it's roughly 10 years old. Alright, let's open it up. And in here there's the remote AC DC in power switch, which controls the switched outlets. So you connect this to your receiver, and then the receiver gets to control these switched outlets. So I'm gonna remove that using this tweezer. Okay, so there are 4 rubber feet in here. Let's just pop those off. They're just glued down. Comes off pretty easily. Ooh. One's breaking apart. Okay. A bit torn up there. All right, 4 screws. Let's pop the end caps. So that came off easily, and the other end, gotta be careful with the other end because that's where all the wires are connected. I don't want to sever anything. So now we just slide the back cover off. A bit stiff. There we go. Alright, let's put that aside. Okay. Well, you could see there's a brown spot in here and over here. Yeah, definitely looks burnt. And the solder doesn't look good as well. So here's the close-up shot of the board. and the burned spot. There you go. And there's the other one. So just 2 burn spots. Alright, let's remove this board. So there are 3 screws over here that needs to be removed. I think before we could remove this board, we also need to remove these 2 ground screws over here with all the green wires so that we could pull the board out. After carefully bending all the wires, I finally got the board out. I wanted to make sure that I didn't overbend the wires and break them and cause more problems. So here's the main board. Pretty populated. I mean, I like looking at this stuff. I mean, it looks really well built, man. None of the mouths appear to have blown up or burnt up. The only thing that looks damaged is this capacitor and resistor over here. This one and right over here. And when I plugged it in, this resistor was extremely hot within seconds, as well as this gray resistor. And then I tested this capacitor over here, this 47 microfarad 100 volt capacitor, and I was getting some odd readings, so I'm gonna take that off and do a proper reading on that. But this resistor, it gets so hot that all the color bands on it have worn off or discolored. And I measured it, and it read about 3.5 kilo ohms of resistance. But you could see how badly burnt the PCB is. On this side, where's my tweezer? Okay, on this side, this resistor also gets hot, but not as hot as the other one. But this, you saw that the PCB was also starting to get charred. So I'm guessing this 3.5k ohm resistor just toasted this capacitor, so it's no longer good. And you could see when I tapped on it, it barely moved because the padding, the solder pad underneath was all burnt up. It's lifted off the PCB, so it's barely anchored in. Alright, let's take that capacitor off. So I plugged the unit in to record the buzzing noise that I heard. Hopefully the camera picks it up. It's hard to pinpoint which one's making the noise, whether it's these giant chokes or the 3 relays. So there's 3 relays here and 2 of them are active. I can't tell where the sound is coming from. So it could be any of those 5. Focus, there we go. So I removed this 47 microfarad capacitor over here. And you can see how badly burnt the PCB is underneath this resistor. So this resistor is in line with this diode. And what's interesting is this diode symbol underneath the resistor. I don't know why that is. So I'm going to replace this capacitor as well as this one. I'd hate to go back later on and have to replace this, so I might as well kill 2 birds with 1 stone. Yeah. And I think I'm going to have to lift up this resistor off the board so that it doesn't heat up the board as much. So I'm going to have to find a way to lift that up. So here we are, all repairs completed. I've replaced the 247 microfarad 100 volt capacitors with United Chemicon branded ones, and for the 3.5 kilo ohm resistor I extended the lead using a leftover lead that I cut off from another resistor and wrapped it around the end and soldered it, so you could kind of see the helical loop. Will it focus? Well, you could kind of see the loop around that end near the board. So I did that for that resistor as well as for that resistor over there. Yeah, it's hard to see that with the camera. And as you'll notice, there's also no noise. The unit is already plugged in, and I've connected this desk lamp on it. So this controls the switch for the light. And it's pretty much silent. So for all intents and purposes, I'd say this is fixed. So just for fun, I wanted to see how the power relay works. So I connected a 5 volt DC to the remote power switch. So that's the relay. You could see the actuating arm move. So basically, every time you plug in the power surge protector to the wall, you hear this click, and that's the click that everyone hears. But this relay is for the remote power switch. The other 2 to the right of it is the main relays. And just for fun, I'll show you just how hot these resistors get. This is the hottest one. This one reaches up to 120 degrees Celsius. So I've hooked up a thermocouple to my multimeter, and I'm touching the center of that resistor. So that's about, and I'm in an air-conditioned room too, so right now it's 109 degrees Celsius. So that's pretty hot. That's more than boiling water temperature. And then for the other one, this one reached 90 degrees. I've also got a fan blowing, so that affects the temperature as well. But imagine how hot this thing gets once everything's put back together in an enclosed box. So 83 degrees. There's no way you could touch that. Now in closing, I just wanted to show you the two capacitors that I removed. These ones are branded Junfu, 47 microfarad, 100 volts, and rated for only 85 degrees Celsius. Now the replacement that I use are rated for 105 degrees Celsius, so they're more appropriate for the working environment they're exposed to. Over here is an ESR meter. Sometimes you can't tell whether a capacitor is good or not. Like these aren't even bulging and they're not leaking. So sometimes you just have to take them out of circuit and measure them. So let's measure this bad one. So its capacitance is measuring 1800 picofarad, which is roughly 0.0018 microfarad, which is way off from 47 microfarad. And the ESR is measuring 17 ohms, which is way off. And then the second capacitor, this one is not too bad. The ESR for this one is 700 milliohms. And the capacitance is still 47 microfarad. So it's measuring okay, but considering its age, I'm throwing both of them away. So there you go. I hope this video will help you in your own troubleshooting. Until next time, happy YouTubing.